In this episode of Finno-Ugric Machining we are dealing with this. Well, it's raw material for the butt of this thing. We are going to put this here. So we need to make a thread inside the thread here and a bearing housing. So that we can fit a bearing here. Well, it's a simple part actually, but it has to be made quite accurately. Otherwise it will bite when you put it there, and the bearing and everything, it will bite if it's not accurately done. So let's go on with this one. So for the hand side of this rotating thing, there is a bearing housing which is screwed into the end of that tube. So what I will make here, this is a piece of material I have already put it into the chuck. It's reasonably straight. Well, since I don't have a 4-jaw chuck with separate jaws, I will be using this one, which has self-centering jaws. And it's a little bit unsafe to hold this kind of material which is not machined with this type of chuck, because this is probably not round. So I had to find out a place where all the jaws are touching. Well, that's not always possible, but in this case I think I found a reasonably good place. So now I will first of all face it, and after that I will bore this one to the minor diameter of M32./1. And let's see, after that we are going to do some threading. So, but let's first clean this up a little bit. The target diameter is 13.77 millimeters. That's the minor diameter for M32/1 thread. Now the diameter is after the last 0.3 millimeters, it is 13.47 millimeters. So I'll just take 0.3 millimeters more. Let's see if did I already set it for that? Yes, I did. So I will now skim the last 0.3 millimeters and we should be right on the dimension. Yeah, I have been using this all the time, so this also includes the last pass. You should not stop using it if you started to use it, so the cuts must be equal. So last 0.3 millimeters. There you go. So here is now the next task is to make the thread at this end of the piece. And I have already touched the surface and zeroed my dial here. And after that I made a groove inside there. If you can see it, you can actually see it there. The depth of this groove is 1.25 millimeters. Our cutoff depth for this thread is 1.23 millimeters. So let's now see how this goes, and wish me luck. This is, as you can see, I'm running this backwards, so I put it down to the hole. Then I dial in the first, let's say, 0.2 of a millimeter. And then I engage the half nuts. Oh! That was bad. Wrong direction. Yeah, it's wrong direction in every way. Okay, so what I need to do now is to disengage the half nuts if I can. Yeah, these jam pretty tight. Oh yeah, that's accidental. Hopefully I didn't destroy my... I have to draw it back. And now I should be able to disengage the half nuts, yes. And as you can see, we have a small thread there. Okay. It didn't destroy our work, which is good. In the correct direction. I was running it, I should be running this backwards, and I was running it as normally forwards. And now it should actually do the trick. So let's see. So this is now the correct direction, and then I engage the half nut. Yeah, much better. that was our first part of the thread. And then let's take up to 0.5 millimeter the depth. We can actually check the thread. Let's do that. It's a little bit tight. Yeah, okay. But not much. So, that was quite a heavy spring pass, being a spring pass. Let's see, that might just do it. Yes. Just another spring pass and there you are. Then we are home. Yeah. Oh. I don't want this to be, I want this to be rather tight thread, but this is too tight. Well, it might work if I skim the top of the threads. Let's see now. This should now work all right. If I'm not correct, yeah, it works nicely. So now, because this has a thread, and it has the capability of rolling your finger in, so I don't stick my finger in there. I'm using a wood block here, and with this one I will now do the sticking a finger in a threaded hole. That's really dangerous. Well, it looks a lot better. Yeah. Adjust the feed. That's adjusted. Let's take it very slow. That way. Now, and then 0.2 millimeters. And this will create a lot of stringy chips. I'm pretty sure of that. Well, yeah. Okay. Let's go. And I feed with the compound a little bit, like that, and then come back back and paste this manually. There you are. Okay, let's paste this. That's dangerous. This is horrific. Ooh. Well, it's quite crispy. Oh yeah, we are there. So let's start. Nice. Okay. Then I just chamfer this backside with the same tool. There you are. Yeah. So next step, we are going to bore this one a little bit larger so that it fits a bearing, and the bearing will be like this, and this one as well will be a shrink fit. I'm roughing the hole in 0.3 millimeter steps. And the reason is the chip evacuation. It's very hard thing with this type of hole. It makes a bird's nest, and well, you will see. The target measure is 47 millimeters or hair under, 5/100ths of a millimeters under. We are at the moment 46.75. Okay, so we have 2/10ths of a millimeter to get off from that. I will take this in two passes, each 0.1 millimeter, and then we should be done. But this is, well, it's lukewarm. It's a little bit, this can impact the measurement, so I will wait until this cools down totally. So it's 46.88. The goal is, well, 95. So okay, now I will feed with the compound a little bit. Just a tiny amount. Like that, and then I will face the back side. There you are. Well, let's try this out. You can tell whether it, yeah, it doesn't go there. It wants to start barely, but it doesn't go. Very good. And now we will take just a hair off from that, so we can put it straight into there. So we take 5/100 of a millimeter away from the, and this is a manual operation. I will just take a little bit like that. That should, now the bearing will go in that amount I took away, but not more. So now it should go there for the beginning of this, and it did, and then it doesn't go. Oh, yeah, I believe this is going to be just fine. Now we just take care of some of these chamfers around. Okay, once again we are shrink fitting a bearing into there. I have here the bearing I want to shrink fit. It's this one. It does go. I made this small so I can. It starts easily, and after that it now it doesn't drop in there. It's clinically clean. So now, because this has a plastic part, I cannot warm this not like 200 degrees. It would be probably a disaster for the plastic part. So let's warm this up a little bit less. Now it's a little bit over 100 degrees. And now I put the bearing in there. It should drop in. No, it did not drop in, so I have my backup plan here. So there you are. You always need to have a backup plan in case it doesn't drop in. So now this part is ready. So I will now demonstrate how this goes. So we have this tool holder with the 32mm hole. Goes into your tool post like that. And then you just take this tube, put it through, put it through, yeah, put it through from here, like that, and then this one screws in from this side. Yeah, it's a 1 millimeter thread, so it's a little bit hard to start sometimes. Oh yeah, and one nice thing about these tool holders is this middle thing here. These two screws here are used to tighten this. This one is used to loosen it. So when I loosen this one like that, it's already like tight there. Well, yeah, I could probably like that. And now if I tighten those, it will sit there like nothing else. So now, well, it goes like that, and then you can put your tooling in this side when there is this spindle in, and there will be a Morse 2 taper and also a flange so that you can put something else than your drills or whatever Morse 2 things there. There will be a drawbar this side going in, and it will then you can put it in any desired position. Normally you would probably use it like this. So then you can rotate your thing. For example, so where was I? There was a lens error in my camera. So yeah, so you can then rotate your, for example, your ball turning tool here. Well, the only thing about this is that the height adjustment this way, this axis, is not usable. Well, you have to center it, and it must stay that way. Actually, you can adjust it, but it's and then you should be able to adjust the radius here. Well, that's more feasible, but yeah, okay. Anyway. In the next episode of Finogrec Machining, we will be making the flange in this side, and then yeah, that will be the next task to do. It's another round piece of material with 25 millimeter hole in, and well, it's not 25 millimeters, it's under. And then there will be a shrink fit shaft which then will grip into that one, and then we have it there. Okay, yeah, and that will be in the next episode of Finogrec Machining. Till then, see you!